All right, 53, linear quadratic systems. So we're going to do the first two algebraically, and then we'll do the other three graphically on the graphing calculator. So the first one, what we're saying is we've got a quadratic and a line. Now the line is a horizontal line. Y equals 3 is a horizontal line. So we want to know, when does this one equal that one? Since they both equal y, we are all set to algebraically set them equal to each other. All right, that's really the trick. After this, it's just like you did before, because now we are solving it just like we would normally. -3 is going to be added to both sides, and then we can see if we can factor, and we can. So that's nice. It looks like it actually hits at two locations, +3 and +2. So to answer the question, determine the number of solutions. That's our answer. Our answer is 2. Okay, 2 solutions. All right, now with this one here, we've got this guy. Does he hit this line? Now, y is not by itself, so we are not in a position to set them equal to each other. We have to take this step here. We got to move this 4 over to the other side. Now, if I do that, then I have a line that's ready to set equal to that quadratic. We set it equal to each other. Do a couple algebra moves here. We're going to move the 2x plus 4 over to the other side by making them negative. And that gives us a new quadratic. Then this quadratic we actually solve just like we would with other methods. We're going to try to factor, but we'll find that it is unfactorable. So our last resort actually is to do the quadratic formula. And by doing the quadratic formula, we actually find that the discriminant is -8, which means that it does not hit. So there is no solution. If we were to graph this, the line would be underneath the quadratic. Okay. All right. So now let's go ahead and take a look at 55. I'm going to go ahead and just do y equals here. Oh, I'm in parametric mode here. Let's get out of there. Oh, whoop, don't want to go to window. There we go. Clear and clear. So my first y1, according to 55, is x squared plus 4x plus 3. All right, so that's going to be a green quadratic on my screen here. And then the 55 is I've got to move the 2x to the other side for a 2x plus 6. Okay, so that -2x had to be move over to the other side. Now I'm going to do a zoom standard because I want this to be in its default. Okay, so it looks like we're going to solve this. So you can see that I actually hit it at 2 locations. This one right there, which is -3, 0. And this one, it looks like, is +1, and that's 1, 2, 3, 4, 5, 6, 7, 8, 1, 8. All right, now if you want to know exactly, remember you can hit second trace for a calculate, and we can do these intersections here. And I'm going to do that real quick, okay? And it's asking me the first curve is going to be right there. The second curve is going to be right there. We're going to guess that it's probably about there, and it looks like the intersection is -3, 0, so we were good. Okay, so now we're going to do another one. Second calculate the intersection. But now we're going to move over to here, closer to that one. Okay, we're going to go on the other side there, and the guess is right about there. And it says +1, +8. So those are the 2 intersections, okay? Now graphically, we could also zoom in. So, use this however you need to, okay? There's plenty of different ways. If you need to zoom in to find that point, or you can find that intersection. We've used that before. All right, and then we've got this guy here. Now we've got x squared plus 2x plus 7. So I'm going to just write over that. And then y2 is x plus 7, so I'm going to delete that. Okay, let's go ahead and take a look at that. We'll graph that. Okay, it looks like that's going to be a little... I'm going to zoom in now. It's a little hard to see. So I hit zoom, okay, the zoom button, and I zoom in, and I'm going to scroll into that location here. Get a little closer. Okay, 2 spots. Looks like this guy's right on. Okay, that guy's right on at... That's got to be at 0 7. Okay, 0, 7. Now what's this guy? Okay, now that's basically positive 1, 6. Okay, so you can see that they're so close that the only reason why there's decimals there is because of the pixelation. Okay, it won't allow me to get any closer. But the intersection is 1, 6, and then 0, 7. Okay, so that's my solution there. And again, I could have used the intersection part there, but there's no need for that because I'm going to use it on the next one. 57. An archer shoots an arrow to a height given by that equation. So let's go ahead and just clear these out. We're going to type that in, -5. They have a t, but when we're dealing with functions, we're just going to use x. T is just a convenient way to express time. 0.0. Okay, so now they want to know a target sits on a hill represented by the equation represented there. At what height will it strike the target? Okay, so let's type in that equation. 0.75x minus 1. So this is good to go. Okay, we'll graph it. We'll do a zoom standard, and we'll see if it actually, can we see anything? Okay, so it looks like it hits the target at 2 spots here. Okay, so let's zoom out. Okay, that's too far. So that's the problem with zoom. So what I'm going to do is I'm going to actually go to the intersection. Okay, and I'm going to hit, since I'm super close there, I'm going to go 0, 0, 0. Alright, so that's my first intersection. I would write those points down. 0.04, y equals -1. However, that doesn't make any sense. Like, is that underneath the ground? You know, like, do I hit the target at -0.04 seconds? That doesn't make any sense either. Okay, so that is just not going to be a reasonable answer. The reasonable answer is over here. It's that one right there. So let's go second calc, intersection, and we're going to move around the quadratic. Okay, we're going to get real close there. Second curve is red, right about there. That's our guess. And our intersection is right here. So at about 3 seconds, he will hit the target at 1.6. What is it, feet? Meters. Okay, so I was going to say 1.6 feet is not very tall. So 1.6 meters, which is like, 10 feet. And this, he will hit it after almost 3.5 seconds. All right, that is it. Good luck on your tests. I hope everybody has a good weekend. All right, see you.